Okay, this is Mr. Weideman, and this is AP Physics Homework Help. This is on the static equilibrium problems assigned. This is number 2.20, and I've started out with the free body diagram. I have a 40 Newton weight suspended by two cables and kind of a weird little configuration here. And we want to solve for the tensions in the cable. All right, there's two things pertinent to this problem. The first is static equilibrium. Equilibrium tells me F net equals 0. So that means that T1, T2, and W, when added together as vectors, will all cancel out. Now, if the vectors cancel out, then their components must also cancel out. And that's going to be hinge pin to solving this problem. The second thing that we have to do, and it's more of an algebraic thing than a physics thing, is I have two unknowns, T1 and T2. All right, so by the fundamental theorem of algebra, I can only solve for as many unknowns as I have equations. So what I'm going to need is I'm going to need two equations. And we can do that. What we can do is we're going to use independent dimensions. We're going to use the left-right dimension to develop one equation. Then we're going to use the up-down to develop the other equation. Okay, so first of all, how do we handle two-dimensional vectors where there is only one way? We have to break them up into components. Let's start with T2. Okay, if I look at T2, there is a component of T2 that pulls downward. And then there's a component of T2 that pulls over to the right. Now, if I knew the magnitude of T2, and I have this angle, I could use a little bit of trigonometry, and I could get these values. But I don't have T2, so I have to carry it as a variable. Okay, likewise, let's look at T1. T1 pulls over to the right and up. Again, using trigonometry, I can come up with an expression for the side adjacent and side opposite, or the leftward component and upward component of T1. Now that I've got T1 and T2 into components, I'm no longer concerned with T1 and T2. They do not belong in my calculations. Their components belong in our calculations. All right, well, let's hit the simple one first. Okay, I know that all of these vectors have to cancel out, which all the left vectors have to cancel out with the right vectors, all the up vectors have to cancel out with the down vectors. So let's look left-right. That's going to be our simplest to start off with. Well, I have T1 cosine of 60 to the left, T2 sine 70 to the right. That's these two vectors marked with the two hash marks. They have to be equal to each other in order to achieve equilibrium. Okay, since I know I'm going to have to do system of equations here, I'm going to go ahead and start a little bit of algebra right here. I like to solve by substitution. So I just do a little bit of algebra right here. I take sine of 70 divided by cosine of 60. And what this tells me is it tells me that the tension in T1 is almost double the tension in T2. And that's going to be helpful.
Mr. Hunley, please dial extension 32258. Mr. Hunley, extension 32258. Thank you.
Thank you, Mr. Hunley. Okay, there's another problem where it says that I think the tension in T1 and T2, they're able to hold 80 newtons of force. Well, which one is going to break first? Well, obviously T1, because it's holding almost twice as much tension as T2. All right, but that's for a future problem. Let's get back to this. Okay, so there's one equation. Now let's look at all of our vectors that are operating up, down, and see what's going on there. Okay, so I have three vectors. I have the vertical component of T1 pulling up, the vertical component of T2 pulling down, and the weight pulling down. Our physics is done. Now what we have left is algebra. The first thing I'm going to do with my algebra is I'm just going to perform a substitution. Wherever I see T1, I'm going to replace it with 1.9 T2. Okay, now sine 60 and cosine 60s are just merely numbers. So I can put that in my calculator in the degree mode and get two numbers. And so I'm going to have two like terms for T2, which I'm going to then combine, take the coefficients, divide both sides of the equation by their common coefficient, and then I'm going to get an answer for T2. And then I'm going to take T2, multiply it by 1.9, then I'm going to get the value for T1. All right, this should be all you need to solve this problem. Thank you for listening.